Hello friends. In the previous lecture, we have discussed the introduction part and the uses of the OOPS concept. Then in this lecture, we are going to see the examples of the each OOPS concept. The first one is class and object. Here, here you can see the example of this class. Okay, let's explain me this to you. Here, first line class student. Here, student. Here, first line is the blueprint for a student, then second line string name, and third one is integer roll number. Here we have, yeah, this is the properties every student has. Then wide display, this is the method to show student details. Then new then here you can see s1 is equal to new student. uh, at line number 10, here we have creates an object, means real student record, and s1 dot display is the print detail. Means in this example we created a class called student, and inside it we defined two properties, name and roll number. This represents the data every student will have. We also created a method called display, which shows the student details. When we write new student in bracket dot 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 bracket complete, we are creating an object, a real student record. So in this case, the student name is Shubham and roll number is 101. Finally, we call s1 dot display to print the details. The strategy here is organization. Instead of writing random variables, we group them into a class. Once we have the design, we can create multiple student object without rewri- rewriting the code. So here you can see the output is name, roll number. So why we use it? Organize code into reusable design. And what is our strategy here? Treat a class like a blueprint. Once you have design, you can create multiple objects. So in this way, we have studied the first example for the class and object. Then second example is encapsulation. Here in the encapsulation, the second line private double balance is showing balance is hidden, and the line 4, you can see the deposit wide deposit double amount. It's showing safe way to add money. Then get balance, then get balance here is safe way to read the balance, and a dot deposit 500, it's showing the deposit rupees 500. Then a dot get the balance, this line shows updated balance here. So encapsulation means hiding sensitive data and controlling accesses to it. In this example, we created a class bank account. The balance is marked as private, which means no one can directly change it from the outside. To safely add money, we use the deposit method, and to safely read the balance, we use the get balance method. When we deposit 500, the balance increases. Then we print the balance using the safe method. The strategy here is protection, just like a bank locker. You can't open it directly, you need the right key. So encapsulation ensures data safety and prevent misuses. So why we use encapsulation is to protect sensitive data. And here what strategy we use? Hidden. And why we use hidden the data private and allow controlled access through methods. Then see third method. Third method is inheritance. Here inheritance means code from the inheritance means reusing code from a parent class. Here you can see the first line, class vehicle. It's showing parent class with method start. While class vehicle, it parent class with method start. So then class car extend vehicle, line number 7, class car extend vehicle, it car inheritance vehicle behavior. Then line number 14 and 15, C start is car uses parents method, and C drive is car adds its own method. So here in the inheritance, we created a parent class vehicle with a method start. Then we created a child class car which extend the vehicle. This means car automatically gets the start method when we creates a car object. We can call both starts from the parent and drive from the child. Here the strategy is reuse. Instead of writing the same logic again, we put common feature in the parent and extend them in a child class. So this saves time and avoid duplication. Here you can see the output, vehicle started and car is driving. So in this way we have studied the example of the inheritance. Now next example is for polymorphism. There are two types, one is override and another is overloading. So first we can see the example for the override. Here polymorphism means many forms. The same method name can behave differently depending on the object. In this example, the parent class animal has a method sound. Animal has a method sound, and the child class dog override it with its own version. When we call the d dot sound, the dog's version runs and it prints dog barks. The strategy here is flexibility. The same method name can adapt to different situations. This make code more powerful and easier to extend. So we use this overriding is for same action behaves differently depending upon the object. So now let's see example for the override. Here we see method overloading. The class MathOps has two methods with the same name, add, but different inputs. If you pass integers, it uses the integer version, and if we pass the doubles, it uses the double version. The strategy here is readability, and instead of creating different method names, we use the same name and let the program decide based on the inputs. So why we use this overloading method? The same method name but different input. Use overloading to make code flexible and readable. Here you can see this output 15 and 10. So yeah, you can try yourself once. Yeah, go and search one compiler, and after that you can study this example with yourself. You can understand. Then a last method is abstraction. Here abstraction means hiding unnecessary details and showing only the important part. Here we created an abstract class shape with an abstract method area. This means every shape must have an area, but we don't define how. The child class circle provides its own formula for area. When we create a circle with the radius 5 and call c dot area, it calculates the area using the formula. So the strategy here is simplification. Student only see what's necessary, the concept of area, without worrying about the internal details. So here abstract class shape is abstract mean incomplete design, and the class circle extend shape is circle provides actual formula. Then new class is creates a circle with the radius 5, and c dot area means calculate the areas. So we use this method abstraction for hide unnecessary details and use abstract class to define what should exist but not how. So in this way we have studied all these five oops concept, that is class and object, encapsulation, inheritance, polymorphism. In that polymorphism, there are two methods, overriding and overloading. Then last method is abstraction. So in this way, we have studied all these oops method. You can study with this example by yourself. You will get understand all these things. So studied. Thank you.